So let me go through a little more on animal diseases, then we'll take a break, I think. The next animal disease that I've probably spent most of my career on is malaria and vector-borne diseases, okay? So malaria kills about 3,000 children per year. Over 1 million people die a year of malaria. No vaccine is available. It looks like we're getting close to one, but even so, it'll only be partially effective. And one of the big concerns is global warming, and will that change where malaria, where it will be? I mean, malaria used to be in the U.S., used to be right in New Orleans, along with yellow fever. In fact, malaria went all the way as far up north as Minnesota when we first came in. Okay. It's not now because not so much of screen doors and air conditioning is our biggest defense, in fact. So here's where malaria is today, and the question is where will it be in 10 years or in 20 years? Okay. Again, we have these SIR models. E stands for exposed but not infectious. So when you get bit by a mosquito, the human becomes exposed to malaria, plasmodium, but not infectious. After a while, it develops, become infectious. A mosquito or a vector will bite it, infect the human, and the mosquito becomes exposed. And then later the mosquito becomes infectious, and later the human can be recovered. So now we have to work with all 7 of these components in the model. And when we write the model out, so this was done in joint with Nicole Chitness, who was a graduate student of mine, who was Kenyan. Now you went to school with Nicole, right? So at University of Arizona. And he grew up with malaria all around him. And his goal was to find some way, his skills were in mathematics, some way he could apply his skills to fighting malaria. And I asked him where he works today. He's funded by the Gates Foundation to fight malaria. He spends half his time in Africa, a lot of his time in Basel, Switzerland, the Swiss Tropical Institute. He says, well, in mathematics, you know, if you get a 1% advance of what everyone else has done, no one cares. 1% isn't enough to worry about. But in malaria, if you can save 1% of the people that die every year, you're talking about saving 10,000 people per year. You know, what other field could he work in, he asked me, where a 1% advance could save 10,000 people? And the person is really living his dream. He's having an impact. What he's doing, he's taken this model and he's done sensitivity analysis. Sensitivity analysis is we have a fixed amount of money. How can we spend it to save the most number of lives? We can buy mosquito nets. We can buy insecticide. We can buy mosquito repellent for people. We can give them treatment for malaria. We can vaccinate them, even if it's partial. We got all these different ways we can spend the money, but we only have a fixed amount of money. How can we save the most number of lives? Okay? And by so with field data, he's actually testing his models. They actually go in a village, and they'll give everyone a mosquito net in this village. And see, you know, and they predict how many cases would be without it, and they look at how many cases with it, and they see how well it is. And when you look at this model, so these are all the different things that you can use it for. Yes, what is the epidemic most sensitive to? Okay. And it turns out there are 3 things that it's most sensitive to. First is the incubation time in the mosquito. How long a mosquito, how long does it take in this exposed state? So a mosquito gets infected, it's exposed for a long time. Mosquitoes live 12, 14 days. It can be exposed without being infectious for maybe 6 to 7 days. Okay, how long this period is. The next one, which really is how it turns out how long the mosquito is infectious. The next thing is the biting rate. How many times does a mosquito bite during a lifetime? And the last time is the recovery rate. How fast do humans stop infecting mosquitoes? So you take an infected person, you treat them, then they no longer can pass it on to mosquitoes to infect other people. Okay, and so here, again, we can look in this terms of R naught. So R naught is 1, R naught is 10,000. I mean, one infected individual can infect 10,000. Okay, as a function of the number of infectious bites received by a person per year. Okay, so how many times people get bitten per year? If people get bitten 700 infectious bites per year, that's when you have the 1,000. And so you can see if we can cut down the number of times people get bitten, we can drive it down. The next one is the incubation period. Now the reason that's important, this is how long it takes the plasmodium for an infected mosquito to become infectious. If it's infected on day 0, and the average and the temperature is 15 degrees, it takes 30 days before that mosquito is infectious. If the average temperature is 30 degrees Celsius, it only takes about 7 days for that, or 8 days for that mosquito to become infectious. Okay? Well, here's the mosquito lifetime. These mosquitoes will never become infectious because they'll die before they ever become infectious. So if a mosquito, say, lives 12 days, and the average temperature is, say, 30 degrees, they become infectious after about 8 days. So if a mosquito bites someone on day 3 of their life, 8 days later, on the 11th day of their life, they're infectious. They got 1 day to pass on the disease. That's it. On average, a mosquito that bites an infected person never passes on the disease. The average time that a mosquito is infectious is less than a day. It might be a half a day. Okay? So what can change? Well, if the temperature goes up by 1 degree, this curve takes 1 less day for that mosquito to become infectious. So if an average mosquito is infectious for half a day, temperature goes up by 1 degree, that mosquito is now infectious for a day and a half. R0 is 3 times larger, just by a small change in temperature. So this is why we're so worried about temperature change. Okay? This just explains it in a little more detail here. So this is R0 is a function. R0 from 0 to 25 is a function of degrees C. So for below 25, R0 is below 1, but then it takes off very, very quickly. Okay? I think this is a good place for a stop. I'm going to stop here because this is the end of the first half of the talk, but the beginning of when I actually got into the business.